Hello, this is my English speaking practice, and I'm talking about my tech study. And yesterday, I've learned about CA bundle. That is a file that contains root CA, root and intermediate CA certificates. And yeah, in this stream, as my English speaking practice, I will explain something in English, and I will have AI review in terms of English grammar and technical. Yeah. And after that, I will retry it because it's important to speak in my words. And finally, I will refine it. So this is the final version of CA bundle explanation. A CA bundle is a file that contains root and intermediate CA certificates, and it's used in TLS connections. TLS is a protocol for secure communication that verifies a server's identity. During the TLS handshake, the server presents its certificate to the client, and the client verifies it using the CA bundle. This works through a chain of trust. A root CA can authorize intermediate CAs, and those intermediates can issue server certificates. So the client doesn't need to have every single server certificate. It just needs the trusted root CA certificates, and sometimes intermediate ones. All of these trusted certificates are collected in the CA bundle file. That's why it's so important the client uses it to check whether the server's certificate is valid or not. In addition, CA certificates are usually distributed by operating systems or browsers, but you can also download them directly from a CA's website and verify their checksum to make sure they are valid. Okay. And today I will change the topic. New topic. What is the consistent hashing? What is the consistent hashing? The consistent hashing is an algorithm that is useful to determine hashed key in distributed key value store. In normal modulo in no a normal way to determine hashed key by modulo that is not efficient when the node is added and deleted. Because when the number of node changes, it needed to calculate the hashed key again. So it costs in terms of computing. Inconsistent hashing compose a ring hashing consists a structure like a ring like a ring and all of the all nodes are put on it. And between them, the key nodes are placed. And the key nodes indicates the key node corresponds to the node next to itself. When the new node added, it can reduce the amount of recalculation. because I can't explain. I don't understand it completely. When the node deleted, it also can reduce the amount of recalculation. Because the difficult. I gave up. I give up. And the number of changes, when the number of node changes, it needs to calculate the hashed key again. Consistent hashing is an algorithm. Useful to determine hashed key in distributed queue. Modulo. Very difficult. Normally we might use modulo to assign keys to nodes, but that becomes insufficient inefficient when nodes are added or removed. When the number of nodes changes, all keys need to be recalculated, which is very costly. Consistent hashing uses a structure like a ring. All nodes are placed on the ring, and the keys are also mapped onto points of this ring. Each key is assigned to the first node that appears clockwise on the ring. When a new node is added, only a small portion of keys need to be remapped instead of all of them. That's a big advantage. Honestly, I don't understand all the details yet, but that's a basic idea. Similarly, when a node is removed, only a small portion of keys need to be reassigned. Okay. And I want to run about consistent hashing. So I want to compare with the normal algorithm. So server index, how to determine the server index. Like this. So, how to call this existing or old, normal, or naive. Naive way to determine server index is like this. Okay, so this is this assumes the will not change. And this assumes the keys are distributed evenly, equally. The keys are distributed equally. Right. When number of server changes, it when number of server changes, it requires to calculate its server index again because of result of module. Result changes of module, right? Consistent hashing. There are hash server and hash key. Let me consistent hashing. Guide to consistent hashing. Consistent hashing is a distributed hashing technique used in load balancing. The goal is to minimize the need for rehashing when the number of nodes in a system changes. It represents the requests by the client and the server nodes in a virtual ring structure, which is known as a hash ring. The number of locations in this ring is not fixed, but it is considered to have an infinite number of points. The server nodes can be placed at a random location on this ring, which can be done using hashing. The requests are also placed on the same ring using the same hash function. Traditional hashing methods. Here are some key issues with traditional hashing methods explained in easy language. Uneven distribution of data. Traditional hashing methods often leads to uneven distribution of data across servers. When you use a simple hash function, some servers may get more data while others get very little. Scalable problems. A sizable amount of the data must be redistributed among all servers in classic hashing whenever a server is added or removed. As a result, practically all data must be rehashed and reassigned, which is ineffective and result in delays or downtime. Inflexibility with changing number of servers. If your application requires scaling up by adding more servers or scaling down by removing the same, traditional hashing methods struggle to adapt. The entire system becomes unstable and a large amount of data needs to be removed. Node failure handling. When the server fails in a traditional hashing setup, all the data on that server becomes inaccessible until the server is back up or data is redistributed. There is no good way to handle all node failures. Overhead of rehashing. When the system grows or shrinks, traditional hashing requires rehashing of most keys to different servers, which causes a high amount of overhead. Are they same? Practically all data must be rehashed and reassigned, which is ineffective and results in delay or downtime. When the system grows or shrinks, traditional hashing requires rehashing of most keys to different servers, which causes a high amount of data. I don't know the difference. When a server fails in traditional hashing setup, all the data on that server becomes inaccessible until the server is back up. Data is redistributed. There is no good way to handle node failures. What is the use of consistent hashing? Consistent hashing is a popular technique used in distributed systems to address the challenge of efficiently distributing keys and data elements across multiple node servers in the network. Consistent hashing's primary objective is to reduce the number of remapping operations necessary when adding or removing nodes from the network, which contributes to the stability, and dependability of the system. Consistent hashing can be used to share the burden among nodes and lessen the effects of node failures. For example, when a new node is added to the network, only a small number of keys are remapped to the new node, which helps to reduce the overhead associated with the addition. Similarly, a node fails, only a small amount of keys are affected, which helps to minimize the impact of the failure on the system as a whole. Consistent hashing is also useful in ensuring data availability and consistency in the distributed system. Phases working of consistent hashing. The following are the phases involved in the system process of consistent hashing. Phase 1, hash function selection. Selecting the hash algorithm to link keys to network nodes is the first stage in consistent hashing. This hash function should be deterministic and produce a different value for each key. The selected hash function will be used to map keys to nodes in a consistent and predictable manner. Phase 2, node assignment. Based on the hash function's findings, nodes in the network are given keys in this phase. The nodes are organized in a circle. The nodes are organized in a circle. This is good expression. And the keys are given to the node. That is, keys are given to the node that is situated closest to the key's hash value in a clockwise direction in the circle. Situated. Situated. Okay. Nodes in the network are given keys in this phase. The nodes are organized in a circle and the keys are given to the node that is situated closest to the key's hash value in a clockwise direction in the circle. Phase 3, key replication. It's critical to make sure that data is accessible in a distributed system. Even in the case of node failures, keys can be copied across a number of network nodes. To accomplish this, in the event that one node fails, this helps to guarantee that data is always accessible. Phase 4, node addition removal. It can be required to remap the keys to new nodes in order to maintain system balance when nodes are added to or deleted from the network. By only remapping just a small number of keys to the new node. Consistent hashing minimizes the impact of added or deleted nodes. Phase 5 load balancing. Consistent hashing helps in distributing the load among the network nodes to keep the system balanced and effective. When a node is overloaded, portion of its keys can be remapped to other nodes. Phase 6 failure recovery. If one node fails, the keys that are assigned to it can be remapped to other nodes in the network. This enables data to remain accurate and always available, even in the case of a node failure. Let's say we have 5 nodes in the ring and say node 3 fails. Then the range of the next server node widens, and any request coming in all of this range goes to the new server node. This shows that due to use of consistent hashing, only a small portion of keys are affected. So in this case, if the node 3 fails, only this data should change the server index. So this server, this data search for in clockwise direction. So the next data will be node 1. So the so it can reduce the amount of recalculation. It just this data just have to be recalculated. In other for other data, it remains okay. Algorithm. Okay. Choose a hash function. Select hash functions. Okay. Define the hash ring. Represent a ring of hash values as a ring. This ring should cover the entire possible range of hash values and be evenly distributed. So maybe this the result of these hash functions gotta be maybe 2 power of 256 maybe. Okay, and assign nodes to the ring. Assign each node in the system a position on the hash. This is typically done by hashing the node's identifier. Yeah. So it's okay just to hash the node's identifier. That makes sense. And key mapping, when a key needs to be stored or retrieved, hash the key using the chosen hash function to obtain a hash value. Find the position on the hash ring where the hash value falls. Work clockwise on the ring to find the first node encountered. This node becomes the owner of the keys. So if the value is David, it calculates the hash of SHA-256, and that indicates the here, and then it search for this direction. So this node 5 can be found at first, and node additions. When a new node is added, compute its position on the hash ring using the hash function. Identify the range of keys that will be owned by the new node. When a new node is added, compute its positions on the hash ring using the hash function. Identify the range of keys that will be owned by the new node. I see. This typically involves finding the predecessor node and the ring. Update a ring to include the new node and remap the affected keys to the new. Okay, I understand. So in this case, if there is no node 1, if the node 1 is does not exist, Joy, Mike, and Peter is owned by node 2, and when the node 1 is added to the network on the hash ring, and when addition, node 1's hash is calculated and it indicates here. And then it needed to know about the previous node. So in this case, clockwise, opposite clockwise. In clockwise, I don't know. Anti-clockwise, okay. And the node search for in direction of anti-clockwise, because this needed to find the previous node. So, and in this range, in the data in this range will be owned by the node 1. So they are needed to be remapped to the node 1. Okay, so a portion of recalculation is like this. Okay, so it can reduce the amount of recalculation. Just here. Okay, and node removal. Okay, so it's likewise. Yeah, we can calculate similarly. Okay, and load balancing. periodically check the load on each node by monitoring the number of keys it owns. If there is an imbalance, consider redistributing some keys to achieve a more even distribution. I see. But how? How to redistribute some keys? I don't know. So here is the advantage of using consistent hashing. Below are some of the key advantages of using inconsistent hashing. Even as the volume of data grows and evolves over time, consistent hashing maintains the system's efficiency and responsiveness by distributing the network's workload among its nodes in a balanced way. Because consistent hashing is so scalable, it can adjust to variance. It can adjust to variance in the number of nodes or volume of data being processed with negligible. neglect みたいな negligible. Consistent hashing is so scalable, it can adjust to variations in the number of nodes or volume of data being processed with negligible to no impact on the system's overall performance. Okay, so it can be adjusted to variations in the number of nodes or volume of data being processed with negligible to no impact on the system's overall performance. Okay, and minimum remapping. By minimizing the amount of keys that need to be remapped whenever a node is added or withdrawn, consistent hashing makes sure that the system remains stable and reliable even as the network evolves. Increased failure tolerance. Consistent hashing makes data always accessible and current, even in the case of node fails. The stability and dependability of the system as a whole are enhanced by the capacity to replicate keys across several nodes and remap them to different nodes in the event of failure. The act of adding or removing nodes from the network is made easier by consistent hashing, which makes it simpler to administrate and maintain a sizable distributed system. Disadvantage: hash function complexity. The effectiveness of consistent hashing depends on the use of a suitable hash function. The hash function must produce a unique value for each key and be deterministic in order to be useful. The system's overall effectiveness and efficiency may be affected by how complicated the hash function is. Performance cost. The computing resources needed to map keys to nodes. Replicate keys, and remap keys in the event of node additions or removals can result in some performance overhead when using consistent hashing. Makes sense. In some circumstances, the system's ability to adapt to changing requirements or shifting network condition may be constrained by the rigid limits of consistent hashing. Higher resource use. As nodes are added to or deleted from the network, consistent hashing may occasionally result in high resource utilization. This can have an effect on the system's overall performance and maybe this is typo. Not typo. The ability to produce a desired intended result.
Efficacy.
Okay. Efficacy and efficiency, while often confused, have distinct meanings. Efficacy refers to the ability to produce a desired effect or outcome. Essentially asking if something works. Efficiency, on the other hand, is about doing something well with minimum waste of resource. So efficacy, the ability to produce a desired effect or outcome. Okay. The complexity of managing and maintaining a system that uses consistent hashing can be difficult and demanding, and it often calls for particular expertise and abilities. Okay, but I have a question about this. How to redistribute some keys, because the hash function deterministic and the data is not changed, so I don't know how to redistribute. How can we distribute keys if the hash function is deterministic and data doesn't change? I don't understand how redistribution works in that case. Okay, you are asking a very good question. If the hash function always produces the same result for the same key, then how can we distribute keys for load balancing? hash function is deterministic. For a given key, it always produces the same hash value. Yeah. But the assignment of keys to node depends on the ring of node. When you add virtual nodes extra hash positions for a single physical node, the distribution changes. This doesn't change the key's hash, but it changes which node is closest clockwise. So ownership changes. So add or remove virtual nodes for load balanced or underloaded servers. This shifts some key changes from node to another while still using the same hash function. So redistribution doesn't mean recalculating a different hash. It means adjusting a set of nodes or their virtual positions so that the deterministic hash points to a different node. Okay. So I understand that it recalculates the server identifier that is given to hash functions. What? So the result of hash of key is not changed, but the server position is changed. That makes sense. So if there are no need to add or remove the node, because it's okay just to recalculate the position of the node. Is this correct? So I understand that it recalculates the server identifier used in the hash function. The hash result of the key doesn't change, but the server's position on the ring can change. That makes sense. So does it mean that even without adding or removing nodes, we can just recalculate the node positions to redistribute the keys? Is that correct? There is a nuance. Key hash is fixed. Okay. Node position on the ring is based on hash the node identifier, like its IP or host name. If you recalculate node positions with the same identifier, the result won't change, so the distribution will stay. Yeah. I know. To accurately redistribute, you need to add, remove virtual nodes. Or real nodes. Need to change the set of identifiers being hashed. Yeah, that makes sense. The key's hash value never changes, but node positions on the ring came from hashing the node identifiers. If we just recalculate with the same identifiers, the position won't change. Redistribution happens only if we add or remove nodes and or other virtual nodes and by hashing the some server with a Do you want me to also show you a tiny diagram example with keys and nodes? You can visualize why calculation does. I understand that there is need to change the set of identifiers being hashed. Yeah, this makes sense to me. But I don't know why you say addition and removal of nodes. You don't need to. Yeah, you just change the set of identifiers, right? I understand now that you need to change the set of identifiers being hashed. That makes sense, but I'm not sure why you mentioned adding or removal nodes. Isn't it enough to just change the set of identifiers? Oh. If you change the set of identifiers, you are effectively adding or okay. So when we say add remove nodes, it includes both real physical nodes or virtual nodes. Extra identifiers mapped to the same physical servers for load balancing. Oh, that's why I said add or remove nodes. Technically you are right. What actually happened is changing the identifiers, but in practice this is described as okay, I understand now. So adding virtual nodes means can we increase the number of virtual nodes by calculate hash of new server identifiers. I mean, there is no need to remove the existing virtual nodes. Okay, I understand. So we can increase the number of virtual nodes by hashing new server identifiers, right? I mean, there is no need to remove the existing virtual nodes. You can increase virtual nodes by generating extra identifiers for the same physical server. Yeah. Each of those identifiers get hashed to a different position on the ring, which spreads the server's load across more segments of the key space. No need to remove existing virtual nodes unless you want to reduce the server's share of the load. If a server is overloaded, add more virtual nodes for other servers. If a server is underutilized, add more virtual nodes for that server. I totally understand. This is cool mechanism. I don't know the pronunciation.
Mechanism.
Okay, so yes, exactly. We can increase the number of virtual nodes by hashing additional identifiers, like adding extra labels for the same servers. That way, the server gets more positions on the ring, which helps balance the load. And we don't need to remove existing virtual nodes unless we want to reduce the server's share. Okay. So the consistent hashing is an algorithm used for distribute keys in key value stores, and that is efficient compared with naive version of key determination algorithm. Oh. The process is like this. First, it needs to decide the hash function used for hash consistent. And then the all of hashed values are mapped to the ring, which is called hash ring. And for servers, okay. Let me organize the structure of sentences. Consistent hashing overview. Use case. How to say distributed hashing technique. Load balancing. Use case. Key determination. Distributed caches and distributed databases. Yeah. Distributed key value store. Process. Advantages. Disadvantages, I don't know. Disadvantages, function complexity. Performance overhead. But regarding this, when compared with the Mozilla version, it's not disadvantage, right? So the system's overall effectiveness and efficiency depends on how complicated the hash function is. Like this. Okay, and Ah. Okay. Mm. Mm, 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 mm. Okay, I will go with this. Hello. Network error. Hello. Hello. Mm. Hello. Hello. Can you hear me? Can you hear me? Can you hear me? Can you hear me? Oh. Speech to text. Hello. Hello. Oh. Okay, let me talk about consistent hashing. Consistent hashing is a distributed technique used in load balancing, and that is used for distributed systems like distributed key value stores, and it is used for determining key positions. Yeah, and that has a cool mechanism compared with the existing way with Modulo. Yeah, because when the modulo is used for determining keys, when the number of server changes, it needs to calculate all of keys again, so it's very costly, right? Yeah. Consistent hashing is a smart way to determine keys in distribution. Yeah, and when the number of server changes, it works efficiently. So let me explain the procedure of consistent hashing. First, it needs to decide the hash function used for. Yeah, the SHA 256 is used in common, and then it uses a structure like a ring, which is called hash ring, and next it needs to calculate the server's position. Yeah, it needs to calculate hash value of server's identifier, and hashed value can be mapped onto the ring. Yeah, so the hashed value should be all of the hashed value of the hash function should be mapped onto the ring, right? Yeah, and calculate the server's position. Yeah, this is the preparation for consistent hashing, and yeah, for data, it takes same way. It calculates the key position. It calculates the hash of the key, and it determines the position of the ring. Yeah, the hashed value can be mapped onto the ring, right? So the data onto the ring, and it search for a node that own it. Yeah, it search on ring in clockwise direction, and if the server node is found at first, the data belongs to it, right? Yeah, this is the basic concept. Yeah, so when the node is added, the node is mapped onto the some point of the ring, and it needed to calculate the range of recalculation. So I mean, it needed to search for previous server node, right? So it search anti-clockwise direction and find the previous node, and the range is the data in the range will be owned by the new node, so it needed to recalculate, remapped onto the new node, right? And you can do that similarly when the node is removed. Okay, and for load balancing, this is useful because there is a concept called as virtual node. So the virtual node can be increased or decreased by calculate hash of server identifiers. Yeah, right. So if some node is overloaded, the other node, the virtual node of other physical node, need to be increased. So we can increase the virtual nodes of them by calculate a new server identifier. They calculate hash of new server identifiers, right? Yeah, so I mean, one physical node can have a multiple virtual node because it can change the server identifier as you like. Yeah, and the hash of them can be distributed on the ring, so we can increase the number of virtual server nodes. And and if some node are underutilized, we can increase the virtual node by adding hash of server, by changing the server identifiers and calculate the hash of them. We can increase the virtual node of them, right? Yeah, so this is useful for load balancing. That's it. So the advantages of consistent hashing compared with existing the way of Mojiro, it can reduce the amount of remap. As I said previously, the it requires to calculate a small portion of data ranges. Right? Okay, that's it. Thank you. Request cancelled. Can I use this? Hello, let me talk about consistent hashing. Consistent hashing is a distributed technique in load balancing, and this is used in distributed systems, distributed key value stores, or distributed databases, or like that. Because this is used for determining keys, key distributions, right? Yeah. This is a cool mechanism. Compared with the Mojiro version. Yeah. When the number of server changes, the existing version needed to calculate the keys, calculate all of the keys again, so that is costly. On the other hand, in consistent hashing, it can reduce the amount of recalculations. Yeah. So let me talk about the process of consistent hashing. Let me talk about consistent hashing. Consistent hashing is a distributed technique in load balancing, and this is used in distributed system, distributed key value stores, and distributed all like that. Because this is used for determining key distribution, right? This is a cool mechanism compared with the Mojiro version. When the number of servers changes, the existing version needs to calculate all of the key again, so that is costly. On the other hand, in consistent hashing, it can reduce the amount of requests. So let me talk about some consistent hashing. Mojiro-based hashing. Okay, consistent hashing uses a ring and hash functions. Yeah, and the hashed value can be mapped onto the ring. At the point of the ring. And then as a preparation, it needed to calculate the location of the server nodes, right? So it calculates the hash of server identifiers and mapped onto the ring. Okay, and that is a preparation. And then if the data comes, it calculates the hash of the keys and mapped onto the ring, and then determine which node owns the data. So the data search in clockwise direction. And if it finds the server node on the ring, the node can own the data, right? So the data is stored in the node next to them, right? This is a core concept. And let's think about when the node is added. When the node is added, in the same way, it calculates the hash of server identifiers and it mapped onto the ring, right? And then it needed to calculate or search for previous node. So it needed to go in anti-clockwise direction and find the previous node. And the data in range between the node and the previous node gonna belong to the new node. Because based according to the core concept, right? Okay, so I mean, it can reduce the amount of recalculation because the remap of the key happens only between the previous node and new node. Okay, so this is the main advantage of consistent hashing. Repetitive and Hasbira was key mapping, addition of node, key reassignment, smooth phrase, data in range between the node and the previous node gonna belong to the new node. Only the keys that falls between the previous node and the new node need to be reassigned. Small points to clarify. Keys are always assigned to the first server clockwise from their hash. You don't have to search the ring each time physically, just conceptually. I see. When the node is removed, the same idea applies. Only the keys from the removed node's positions to the next node are reset. And this is okay because I don't mention it about when removed. Anti-clockwise search for previous node is just a conceptual way to find which keys now belong to the new node. You can say key between the previous and the new node are reassigned instead. So the consistent hashing works. Consistent hashing works by mapping both server nodes and keys onto a link using hash functions. Each key is assigned to the first server. Each key is assigned to the first server in the clockwise direction. When a new node is added, it's placed on the link, and only the keys that fall between the new node and the previous node are reassigned. This minimizes the amount of remapping, which is main advantage over simple modular hashing. Okay. I'm tired. I got tired. Consistent hashing is a technique for distributing key across servers in a scalable way. It's widely used in distributed databases and key value stores. The idea is to avoid the inefficiency of the simple modular approach. The simple modular approach. With modular, if you add or remove a server, almost all keys need to be reassigned, which is very costly. Consistent hashing solves this by organizing servers in a link and assign keys to the nearest server in the link. This way, when servers are added or removed, only a small fraction of the keys need to be removed. That makes it very efficient for dynamic distributed systems. Consistent hashing works by mapping both server nodes and keys onto a link using hash functions. Each key is assigned to the first server in the clockwise direction. When new node is added, it's placed on the link, and only the keys that fall between the new node and the previous node are reassigned. This minimizes the amount of remapping, which is the main advantage over simple modular hashing. Okay. I've learned a lot. Yeah, it was a good training.